To be able to describe formally this idea of wholes and asymptotes, we use something called a limit. And the limit uses this kind of notation here. It says lim, and you have the limit of some expression, and this is as x approaches that limiting value or the value that is in question. So in this case here, if I have a whole at x equals -3, that means that these two terms cancel out. So I write this as a limit as x approaches -3, what happens? And so to evaluate this, what we can do is we can cancel out the divide by 0. Once we get rid of the divide by 0, we can actually just plug in the value that used to give us 0 here, which was -3. We can just plug it in here and actually evaluate the limit. So if we want to know the y value of that whole, what we can do is we can simplify algebraically, get rid of the divide by 0, plug in the -3, and that gives us the y coordinate of that whole. So in this case here, the whole would be at x equals -3. The y coordinate would be at actually -2/5, or -0.4. So that's where that y position of that whole is. To show a vertical asymptote, in this case, our vertical asymptote is happening at that +2 value. And as we approach +2, this plus on this side indicates that we are actually approaching it from the right-hand side. So that plus does not mean +2. It means that we're approaching the limiting value from the positive side. So it looks like this. I'm approaching the value of +2 on the x-axis from the positive side. So that's what that plus indicates. It's approaching it from this direction. And as I'm approaching it from that direction, it's going up to +infinity. Okay, it's shooting off to infinity. Now, when I approach it from the other side, so this is a notation. It says I'm approaching x equals 2, and that does not mean -2. That means 2. That negative means from the left-hand side, or the negative direction. And so I'll color code that as red. And as I approach the value of -2 from this side now, so I'll put an arrow on here, so I'm approaching it from this side, it's shooting off to -infinity. And so there's our limit, -infinity from the negative side and +infinity from the positive side. And these are individually are called one-sided limits. Allow us to approach it from just one side, because notice that if I'm approaching it from two different sides, I get two different values, and I can't do that as a limit. So these are what we call one-sided limits. If I were to just not put in the plus or the minus like I did here, so this one has no plus or minus on the right-hand side, that indicates this is a two-sided limit. So if I take away the plus and minus, I get a two-sided limit, and because it does not go to the same place from the left side and right side, we say that the limit does not exist, or we sometimes denote it as DNE. Okay, there is no limit because it does not go to one specific place.